Hello, this is Nitin Dahad with the Times, and I'm here at the ARM booth at Embedded World in Nuremberg with Paul Williamson, who's SVP for IoT at the company. Hello, Paul.
Hi there, great to see you, Nitin.
Well, this is always a great show, and you've always got a big booth, and
Yes.
when you walk in, you've got the big ARM poster as well. What's big for you this year? This year, I think you had a big announcement.
We did, yeah. I mean, this year everything is about AI at the edge, and at the show this year and today we've launched our new generation of embedded AI accelerators that are going to be deployed heavily in the microcontroller realm that we'll see in a lot of these embedded devices in the future.
Yeah, just explain a little bit more. It's ECOS, you said.
That's right, yeah. So the new product's called Ethos U85, and we've had a range of this accelerators that partner well with our microcontrollers for a period of time called Ethos. So typically seen with Cortex-M, and you see that in products today from companies like Himax or Infineon, where they've got their Ethos U55 alongside the Cortex-M55 typically. This generation, the Ethos U85, takes a 4 times in performance improvement. It's 20% more power efficient for the same kind of workloads, and it also supports transformer networks, which is a key new technology in the world of AI.
Yeah, I mean, generative AI, transformer networks. So what kind of applications are you seeing already? I mean, you must have been talking to early customers.
Yeah, we talked to a lot of customers, and the first generation of our Ethos products was used quite heavily in sort of lower frame rate sort of applications, things like face detection or posture detection. With the use of transformers, people are able to have more efficient video-based processing than convolutional networks. So one of the early applications is enhanced video systems. So we're seeing it being deployed in industrial for applications like fault detection or defect detection on production lines. Continued work in smart cameras that are getting ever smarter for the smart home, able to really detect events rather than just say a person or not a person. And also in areas like retail for things like warehouse volume and inventory monitoring and these kinds of applications. So a huge range of applications where people are just using more video-based sensing to detect a whole range of events and be able to customize AI algorithms to work in those environments.
And I mean, it's all about AI now. I know everybody I talked to here and the last few conferences I've been at, it's all about AI. What are you seeing in terms of real stuff that you've seen with the AI stuff? I mean, at GTC, for example, everybody was talking about the big chip. But I guess you're seeing quite a range going down to the IoT level.
That's right, yeah. AI is being deployed everywhere, and clearly the big focus has been on things like large language models in the cloud. And absolutely, they have a really critical role in the future of AI. But if we're going to be effective with AI, there are some environments where we're going to need to deploy it locally, whether that be for reasons of latency or cloud connectivity limitations or power consumption. And it can, AI is a way of solving, information problems and doing that locally. So we're going to need a range of scale of solutions that allow you to deploy these in a broad range of devices. But the key challenge, I think, for the industry, and one we're working hard on, is making sure that the software ecosystems stay aligned so that developers can target a range of different hardware solutions, but work in those common frameworks like PyTorch or something similar.
And you're good at ecosystems as a company. You've got some other sort of developments around that?
Yeah, I mean, as you said, we're critically sort of well known for our ecosystem development, and we've got a huge number of software developers and different tools partners that are working in this area. So AI developer flow for edge devices is something we're integrating into our own tools like Kyle. We're working with companies like Keekso, part of TDK, who are delivering sort of ML auto tools for generating new algorithms, or Edge Impulse to allow people to bring models down to the edge. But even NVIDIA, who you mentioned, we have a demo here with NXP where we're taking Tau models and deploying those into an IMX device for video applications at the edge as well.
Yeah, I think I wrote something about a paper published by Apple on I think large language models on the edge, or on small language models. Yeah. So that's kind of where we're all heading, I guess.
Absolutely, potentially. We're seeing a lot of interest in what you could do with a large language model approach in an edge device as well. So we have another demo here where we're running, as you may have seen from others, on ARM, just small cores, A510 type cores, running large language models with sort of 7 billion parameters in about 1.5 gig of memory quantized, allows you to do about 10 tokens per second, which is about the rate of human reading. So you can actually do a fairly good large language model locally on a device. Yeah. But as you say, in an edge device, there's these interesting concepts we're seeing where people are looking at smaller training sets where, rather than have a natural language processor that only handles a couple of keywords, you could actually ask a more open question to your device, like, why is my Wi-Fi not working, to your router, and have it give you a much more intelligible response of, I'm not seeing the connection to the Ethernet or whatever it is in real time.
Well, I think I saw from Synaptics yesterday, they've got that whole kit enabling that to go on there. But you've got stuff with Ambic and others.
Yeah, so Synaptics, a great partner, and it was incredible to see them launch a pretty broad range of performance points in IoT.
Yeah, the Astra, the SL processor, and the Machina.
So some great ARM platforms there as well with sort of acceleration for AI. And here at the show we've also seen Ambic launch a really low power embedded platform that's using our Cortex-M Helium instructions to accelerate AI applications as well. Alif have launched an updated connected microcontroller with an Ethos-based accelerator in it, and Infineon with their PSOC Edge continuing to adopt ARM-based Cortex-M alongside Ethos to accelerate these kind of embedded ML algorithms.
And what are the challenges that ARM is seeing in the market at the moment, and also your customers?
So I think the challenge is that moving world of AI frameworks and software, and I think something like transformers a few years ago was not where people were focused. They were looking at convolutional networks, and so a lot of the early acceleration was targeting convolutional networks. Transformers bring this new matrix by matrix and active weights during the execution, which means a shift to the hardware approach to get the highest utilization of the accelerator, and a need for the software tooling to adapt as well. So we've had to invest to make sure those underlying software frameworks remain completely consistent, but allow you to get the highest utilization in the hardware when you use the newer products.
And the other area, I think, it's probably not your area, but the CSA, the chiplets, how's that going?
So chiplets are a really exciting innovation, less applicable in edge IoT immediately. As you well know, the sort of cost economics that drive the use of chiplets really serve well data center applications, where we are going to see new chiplet initiatives allow people to bring together and effectively compose systems of compute or acceleration to the specific needs. And the ARM architecture really has enabled people to unlock that potential. And announcements like Google's investment in using ARM in the cloud yesterday show that it's really resonating with people, that they want to be able to use customized levels of ARM compute along with their own accelerator to the right tailoring of the workloads, whether that be running YouTube or whatever it is in the cloud. You can really tailor the compute to the optimal solution.
Now, this is probably not the right approach, but can you have IoT chiplets to put stuff in?
It may be something that could happen in the future. I think when I look at it, the cost economics of monolithic still remain so compelling for deeply embedded applications. But there are applications I can see, certainly where we're seeing AI edge platforms, and we even see a growth in sort of module and standard board development. So we see a huge amount of innovation happening on things like Raspberry Pi with various carrier add-ons as a way to sort of experiment with what use cases are feasible. But equally, that can carry to quite moderate volumes in real applications. So people increasingly using compute modules as an approach. So it may not be chiplet level, it might be board level and modules, but it's still very much an area of innovation we see that allows you to compose these different performance of systems.
So what excites you most about what you're doing?
I just think watching the innovation we're seeing on edge with AI and how that sort of marries into cloud. So, one of the things for me that's been most interesting about launching this show is we're here. We've got an FPGA demo of the Ethos U85, and we're still probably 12 months from most developers having U85-based silicon in hand. But with our ARM virtual hardware platform, we're able to see people, recompiling the code they've already generated for the current generation U55s, and seeing in the demo here, we're showing a 10x improvement in performance because it brings more of the transformer network onto that device. So just seeing the rate at which we can see software development happening, and the pace at which ML is improving the way that people can solve problems in the industry is really exciting.
One of the things you mentioned there was code portability, which is actually quite an important one nowadays because of the time to market.
Yeah, absolutely. So time to market's really key for everyone in that supply chain. The pace of innovation with AI, as I keep saying, is huge. And so being able to reuse code and just hit the new platform and be consistent across different hardware performance points is really key. I think the other thing is then also the silicon vendors themselves. So with the Ethos U85, we also brought out a Corestone, which is our sort of reference implementation. And there we put together the Cortex M85, our highest performance Cortex M, the Ethos U85, and an ISP, so that you can do the preconditioning for a camera. And that kind of thing helps, innovators wanting to do new silicon accelerate their time to market as well.
Well, Paul, thank you very much.
Great to speak to you as ever, Nitin. Thanks very much.